welcome to episode 19 in the mathsonlinetuition.com videos. We're starting off with chapter 3, Exponential and Logarithms. After completing this chapter, you should be able to go through these 5 objectives: know the shape of the graph, write an expression in logarithmic form, use the laws of logarithms, solve equations of the form denoted as such, change the base of a logarithm. You will use the above in C2 while studying geometry, sequences and series. The ability to solve equations of the form a to the power of x equals b has many practical uses. Okay, brilliant. So 3.1, you need to be familiar with the function y equals a to the power of x and know the shape of its graph. This is otherwise known as an exponential. A lot of people see it as a graph which, in other words, explodes, i.e. it just increases. So it's a non-decreasing graph. It's constantly increasing. And one of the things that I must point out is that it never touches the x-axis. Okay, so it just keeps going, because when x is equal to 0, you get 1. Okay, so it never touches the x-axis, never crosses at any point. And again, it highlights here C1 chapter 1 for the rules of indices. If you remember, we went over this, and we should be on top of it and recognize it straight away. So the difference in between the figures here is that as the number is larger, when you take that power, it will exponentially grow faster and quicker. So you have 1.5 here, which is a subtle slump, but tends or seems to be tending towards infinity and growing. Again, 2 here to the power of x, you can see that there's a difference, and it's growing at a faster rate. And then you have 3 to the power of x, once again proving that the larger the number, okay, and it's evident if you square 2 and you square 5, the result will be much larger. So self-explanatory. And then you can see here that if you take a half, okay, so 1 over a half, then you will get this type of shape y, because the 2 here, okay, is to the power of 1. So if you take it as y equals 2 to the power of minus 1x, then the graph will be shifting to so that you get the negative y results for the for the negative x, you'll get the positive y results. Okay, and that's why it appears as such. So exercise 3a. So that's very straightforward. You need to know how to write an expression as a logarithm. So you have log, and then you've got subscript a multiply, so n equals x, means that a to the power of x equals n, where a is called the base of a logarithm. Okay, this is just something that you need to recall for later on, because you'll be asked to resolve the questions that you'll encounter in particular forms. Okay, so log a n equals x. Okay, a is called the base of the logarithm. Okay, and just separate the two. It can also be written as a to the power of xn. Alright, make sure to make a distinction between your a and the n and the log. I mean, you want to sort of have, this line is just to illustrate sort of the level, the wavelength that each sort of letter should have with the relationship to the one before and after it. This is coming just below the n, and it gives the impression that it's the the subscript. Okay, and so you've got some examples here. So you've got example 2. So write 2, 5 as logarithm. Okay, you can see that we have a is equal to 2, 5 is equal to x, 32 is equal to n. So how do you write it? You write log 2, and then we put n, 32 equals 5, which is what you can see here, okay? And the base, again at the same time, a is going to be, so the base is going to be equal to 2, okay? And the 5 is the logarithm, okay? So the logarithm is going to be 5. So it tells you here, in other words, you would say the logarithm of 32 to base 2 is 5. So the logarithm of the logarithm of 32 to base 2 equals 5. Once again, that's the logarithm of 32 to base 2 equals 5. So it goes like this, and then it goes like that. So there's a way of saying it, something for you to remember. So again, it asks you here to rewrite all of them as such. This is just an important rule here, okay? So log a to the power, to 1 equals 0 when a is greater than 0. So if a is positive, regardless of what it is, anything, so log 1, anything log 1 to base a, okay, equals 0. And likewise, another rule, log a to base a equals 1. And the reason for that is as follows, because a to the power of 0 equals 1, and once more a to the power of 1 equals a. Alright, so it's self-explanatory. If you know what this represents and what this represents, and you know the rules of your powers, then it shouldn't come as a surprise to you. And so here we've just got some bigger terms to play around with, okay? And we can see that we can just do the following because, and it explains why. Right. 3.3. You need to be able to calculate logarithms to the base 10 using your calculator. So on your calculator, if you look at the buttons, you'll sometimes notice that you'll get this 10x, but also like log, and then you'll see the log button, and the log button pretty much takes the assumption or has a hidden 10 there, okay? So it's log whatever to the base 10, okay, equals, you have your answer. So everything is pretty much 10x equals whatever you have, okay? So if you find from your calculator the value to 3 significant figures, and then you can do these particular working computations. Come on to an important point here. You've got these laws, is what they call them, laws, okay, with regards to logarithms. So one thing that we have to appreciate is log a xy equals log ax plus log ay, okay, and likewise log a xy equals log ax minus log ay, and log ax to the power of k equals k log ax. and finally log a 1 over x equals minus log a x. And you can relate this all to power of indices. So once again, obviously we can see that we would have here the multiplication of x and y is denoted by the addition, the division here is denoted by the subtraction, okay, and this power here is multiplied by the coefficient at the front. In this case it's 1, so we get k. And if you remember, this number here, this 1, okay, becomes a minus 1 when you bring it up top. And then using this rule here, so we have that k in this particular case equals minus 1, and then that's why we have this negative that appears here. Okay, very important for you to realize. Once again, if you understand your rules of indices, then it should be very easy to follow. And you can see they've used some rules of indices here: a to the power of b multiplied by a to the power of c, a plus b, a to the power of b plus c. This is very important for you to appreciate. And so you're tasked with the duties of finding the single logarithm. So you can see what they've done here. They've just, in this particular one, used the rule of multiplication, the rule of division, okay, and the power rules here are used, and the rule of multiplication, okay, the law of multiplication, sorry. And as follows, similar thing. Write in terms of log a or log subscript a x, log subscript a, and then y log subscript a z. And you can see what they've done here. So they've used the law of multiplication, they've noticed it, and then that's why they've got these three here. And then they've used the law of power, okay, and so they've got a term for each x, y, and z. Here you can see the law of division taking place, and then the law of power here. That's how they got the 3 in front. And a similar thing for the following equations. Remember, log subscript a is equal to 1, or log a base a equals 1, and this is how they've been able to get to the final step here. So they sometimes will use different power of law here, again different principles from beforehand in a very subtle way to try and make sure that you appreciate everything in a wholesome, holistic manner. And we can carry on. You need to be able to solve the equations of the form a to the power of x equals b. Okay, what does this mean? So, solve the equation 3 to the power of x equals 20. So, again, we can input this into our base 10, log to the base 10 on each side, and then we'll get this following question, this following fraction here. Using a calculator, we'll get this answer, and then we'll have this value. Okay, so you don't know what x is, but if you put them into log terms, okay, and then you can figure out the answers. Okay, again, this is using log to the base 10, okay, and that's how you figure out that one unknown. Same thing here, they've used the power law, and they've just completed the following steps. So you're just using different sections and applying them to the following questions to try and improve your skills as you go along. 3.6. To evaluate a logarithm using your calculator, you sometimes need to change the base of the logarithm. So you've got here, this is the log formula. This is what it looks like taken as sort of to the power and then you've got here what it might look like when you replace x with a to the power of m. Here you have the power law being used, and then essentially all they've done on this particular side is, if you look carefully, they've changed m for log subscript ax, and so you have this, okay, and then essentially they've just divided it next to end up with this particular formula. Okay, so let's just write this formula out here. So log ax log bx log ba. Okay, using this rule, notice in particular that log a b equals as follows, but log bb equals 1. So log ab equals 1 over log ba. Again, this is just formulas for you that you have to learn. Try to memorize them. A good way is either memorizing them through some sort of special mnemonic trick, or you can just write it out so many times that you remember it. In this particular example, you can see that a is the base here, but b is the base here, and a sort of the number that we have here and here. So you can sort of play around with it, okay, and that's how you can remember it. Okay, and so you've been asked to find the value of log 811, and you can take the different values here and to get the solution. So this is just substituting in the values using the formulas that have been outlined in the beginning of the subsection, and you end up with the exercises and the mixed exercises and the summary of key points. So this is very much like sequences and series, and it's also very much like trigonometry, where we don't write much, but the simple reason is because right now you're going through a particular chapter where the thinking or the mental process is not very difficult, okay, and is not very tasking. All you need to do is appreciate the laws or the rules or the formulas as they've been phrased, and to substitute in the values, okay, and then you'll get an answer. So it's very machine-like, and it shouldn't cause you any problems. And so once again, we'll end it there. Thank you very much for listening, and we hope you'll join us in our next video. Thank you and goodbye.